Alright, we're doing the worksheet on angle properties of circle, and these are questions from paper 2. You should be able to view the worksheet from the link in the description. Question number 1. Two circles with center A and B are each of radius 8 centimeters, which means this length here would be 8, this length here would be 8, and also this is also radius of both the circles, so this would be 8 as well. So all these lengths are 8 centimeters and intersect at C and D. Each circle passes through the center of the circle. Explain why angle CBD is 120 degrees. So we have to show that this angle C to B to D, this angle here should be equals to, this whole angle should be equals to 120 degree. Okay, now how do we show this? If you notice that this is making an equilateral triangle, because this is also the radius and that would be it, which means this angle would be 60 degrees and this angle here would be 60 degrees as well. So CBD will be equals to 60 degrees plus 60 degrees equals 120 degree, and along with that you have to write the reason, which is equilateral triangle. Mention that as well with your solution. Question number 2. The diagram shows a circle with center O, A, B and D, E are chords of the circle. M is the midpoint of AB and N is the midpoint of DE, which means it's going to bisect this chord, and this N is also dividing the chord into the two equal parts. AB and DE equals 9 centimeter, which means these two lengths are equal. These two chords are equal in length. Both are 9 centimeter long. And OM is 5 centimeters. So this here is 5 centimeters. Find ON. Now what's going to be the length of the chord ON? So we know from the property of circle that if two chords are equal in length, which they are in this question, this is 9 and this is 9, then the line joining these chords from the center of the circle would also be equal in length, which means if this line is 5 centimeter, this line would be 5 centimeter as well, and that's our answer. The answer is 5 centimeter because of this property. Next question is, the diagram shows a circle with center O. AB is the chord of length 12 centimeters, so this length is 12 centimeters. And M is the midpoint, so that means this would be 6 and this would be 6. OM is 4.5, so this length is 4.5. Also, we know from the property of the circle that if a line from the center of the circle is bisecting the chord, then it is also perpendicular to the chord. So there should be a right angle over here. Okay, since it's cutting the chord from the middle. Calculate the radius of the circle. So this length here would be the radius of the circle, and we need this length. So we have a right angle triangle actually. This is the radius that we need to find, and then we have a length 6, and then we have a length 4.5, and there's a 90 degree angles in between. So there's a right angle in between, and this is 4.5. So we'll simply use Pythagoras theorem, which is r square is equals to 4.5 square plus 6 square, and then to find r we'll take under root of this, and your calculator will give you the answer, which will hopefully be 7.5. Next question is, A, B and C are points on a circle with center O. Find the obtuse angle AOC. Okay, so which angle is the question talking about? AOC. So which one of these angle is obtuse? This is called the obtuse angle, which is between 90 degree and 180 degree, and this outer one is the reflex angle. So they're not talking about the reflex one. The question is asking for this value, angle of this inner angle, value of this inner angle. Okay, so how do we go about this? This is 130. So this is angle at the circumference. If you remember the property, angle at the center is twice the angle at the circumference. So if this is the angle at the circumference, then its corresponding angle at the center would be this outer angle. So if this is 130, then this should be double of 130, which is 260, because of the property angle at the center is twice the angle at the circumference. So this would be 260, and now we can easily find x by subtracting 260 and 360. 360 minus 260 gives us 100 degrees, which is the answer. Okay, now we have the diagram shows a circle with center O. Find the value of z. So we again will use the property that angle at the center is twice the angle at the circumference. So if this is 58, this would be 116, and if this is 116, then we can easily find z by subtracting 360 and 116. 360 minus 116, which gives us 244, which is the answer. Okay, next we have AB, C and D lie on the circle with center O. Angle ABC is 108. Work out the obtuse angle AOC. Again, where is AOC? So this is the angle. Obtuse angle would be this angle, not this angle, because this would be the reflex angle. So this is the obtuse angle between 90 and 180 degree. We need to find the value of AOC. We have 108. So 108 is the angle at the circumference, and its corresponding angle at the center is this. And we know from the property that angle at the center is twice the angle at the circumference. So the angle at the center should be double of 108, which gives us 216. Now we can easily find the origin angle by subtracting 360 and 216, which gives us 144 degrees. F, G and H are points on a circle with center O. Find the value of P. So we have the property that angle at the center is twice the angle at the circumference. So we have an angle at the center being formed over here, and from the same two starting points we have an angle at the circumference, which is P. So from the property angle at the center is twice the angle at the circumference, this would be 2P. So if this is 2P, we can now easily find the value of P by doing 210 plus 2P equals 360 degree, and then we'll do 360 minus 210, which gives us 150, and then we divide it with 2, we get 75. A, B, P and Q lie on the circle with center O. This angle is 56. Find the value of angle X and angle Y. Okay. So to find angle X, we'll be using the property that angle at the center, which is X over here, is twice the angle at the circumference, which is 56 over here. So we just double 56 to get X. 56 times 2, which is 112. And then for Y, we'll use the property that angle at the angle in the same segment are equal. So if this angle is 56, then another angle is being formed from the same starting point on the circumference, which is Y. So Y would also be 56. So if this is 56, this angle, and we have another angle being formed on the circumference from the same starting points, then Y would be 56 as well. The diagram shows a circle with center O, and we need to find the value of X. So first thing we need to notice is that there's a diameter over here, and we know the property that angle subtended from the diameter is 90 degrees. So this is the angle being subtended from the diameter here. So this angle would be 90 degree, because this angle is being subtended from the diameter, from the ends of the diameter. Okay. So this is 90, and also we have a property that angles in the same segment are equal. So 53 is being formed by these two starting points, and there's also another angle being formed on the circumference from the same two starting points, which is this angle. So this is 53 as well. So now we can easily find x by adding x and 53 and 90, which should give us 180, and from here we can find x, which is 37. Okay, now we have to find the value of angle x and angle y. For finding x, we'll simply use the property that angle at the center is twice the angle at the circumference, which means that x would be half of 110, which gives us 55 degrees. Okay, and then now we have to find the angle y, and now we'll use the property that angles in the opposite segments are supplementary. So x and y are the opposite angles of a cyclic quadrilateral. This is a quadrilateral whose four sides are touching the circumference. So the property would be that the opposite angles would sum up to 180 degree. So you can, if the reason is being asked, you can write opposite angles in a cyclic quadrilateral sum up to 180 degree, or you write angles in the opposite segments are supplementary. So x plus y equals 180. So y would be 180 minus 55, which gives us 125. Okay, next we have in the diagram PT is the tangent to the circle at P. So if this is the tangent and we can see a radius over here, then at the start of this question you should immediately make a right angle over here, because we know tangent and radius are perpendicular to each other. Okay, PW is the diameter, and now diameter is being mentioned, and we should immediately make a right angle over here because of the property that angle subtended from the diameter equals 90 degree. So this angle is being subtended from the diameter. This is the diameter, one corner end of the diameter. This is the second corner of the diameter. So the angle being made from the diameter, angle being subtended from the diameter is 90 degrees. So we have another 90 degree over here. And then we're given an angle 42, and we've been asked to find the angle PWD. PWD is this angle. Now if that's 42, then we can easily find this angle as well by doing 90 minus 42. 90 minus 42 will give us 48. So this is 48, and now we can find the orange angle easily by doing x plus 48 plus 90 equals 180, and from here we can subtract these angles and we'll get 42, or there was actually no need to do this. There was actually one property that's being applied, which is the alternate segment theorem. So why don't we just use that directly? This theorem says that if we have a chord and a tangent forming an angle, here's the chord, here's the tangent, and an angle is being made between the two. Now this angle will be equals to the angle in the alternate segment, which is this angle. So these two would be equal. This is the alternate segment theorem, which says we have a chord, we have a tangent, and there's an angle being made between the two. Then this angle would be the same as this angle being subtended over here, 42. Okay, the next question, which is DA is the tangent to the circle, blah 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 blah. Okay, let's see what information can we use from the question. Okay, so DA is the tangent to the circle. So if this is the tangent, and notice this is the radius, so we'll make a right angle over here between the tangent DA and the radius AO. Okay, and then DB is the tangent to the circle at C, so we have another tangent over here. DB is the tangent, so this would be a right angle as well, because tangents and radius, they're perpendicular, and this will be a right angle over here as well. Okay, then we're told that AOB is a straight line, angle COB is 50 degrees, calculate angle CBO. So first we need angle CBO, which is simply be 180 equals 50 plus 90 plus x. So this would be 40 degrees. So the first answer is 40 degrees. And then in part B, find DCO. So where is angle DOC, sorry. So DOC is this angle. We need this angle. Now we know that angles on a straight line sum up to 180 degree, which would make this angle 180 minus 50, which is 130. So this would be 130. So we have a 130 angle over here, and then this orange line will be bisecting this angle from the property of the circle. So this orange line would be bisecting this angle, so this would be 65. So the answer for the second one part is 65. Now what is this property that I just used? It is that if we have a circle and we have a point over here, and tangents are made from this starting point to the center, and there's to the circle, and there's a center over here, then this line towards the center would bisect the angles, which means it will cut it into two parts. So this whole angle was 130, this orange line would split it into two, so the answer is 65. Okay, in this question we need the size of the angle ACB, we need this angle. Okay, now how do we get to this angle? We're given this angle 142, and we know we can find this angle over here by doing 180 minus 142, because angles on a straight line sum up to 180. So this would be 38. Now if this is 38, then this is also 38. Reason? Because that's an isosceles triangle, because both of these are the radii. So then that makes this an isosceles triangle. Now we can find the upper angle, this angle, by doing 180 minus 38 minus 38, which gives us 104. Now once we have 104, we can use the property of the circle, that if this is the circle and we have a circle and we have an angle being subtended at the center of the circle, then angle at the center of the circle is twice the angle at the circumference. So this would be 52, 104 divided by 2. So our answer would be 52. Okay, next question, we have to find angle X. So let's see. So the first thing that we should observe here is that angle X is being formed from point A and C, and there's also another angle being formed on the circumference from the same 2 points A and C, which is here this angle 85. So now the property is being applied that angles in the same segment are equal. So this angle being subtended from A and C, and this angle is also being subtended from A and C, so they would be equal. Angles in the same segment are equal, so X will be 85 simply. Now we can find Y by summing up the three angles and equating them to 180. So this would give us Y equals 48. It says in the answer, let me quickly check as well, 180 minus 47 minus 85, yes, 48. Okay, and then now we have angle Y and angle X. We need angle W. So for angle W, observe that this line, and this line here, it's forming a cyclic quadrilateral. A cyclic quadrilateral is when the four sides of the quadrilateral touch the circle of center, touch the circumference of the center. So now the property is that the opposite angles in the cyclic quadrilateral sum up to 180 degree, and this property is also known as angles in the opposite segments are supplementary. So which means that angle X and angle W would sum up to 180. So this was 85, X was 85 plus W equals 180, so we get W equals 95. Okay, in the next question we have to first find angle BDE. So angle BDE is this angle. Now notice that these four vertices here are touching the circumference of the circle, so this is called a cyclic quadrilateral. So in a cyclic quadrilateral, opposite angles sum up to 180 degree. So this angle and this angle, they would sum up to 180 degree. So we can do 85 plus x equals 180 degree, which will give us 95. So x equals 95, or the first angle BDE equals 95. Let's call this x. Okay. Next, we need to find angle AND. So where is that? It's this angle, AND. So we need this angle. Let's call it y. So now let's look at the other values that are given to us. This is 19. Angle 19 is being formed from part B and C, the point B and C. And notice there's also another angle on the circumference that is being originated from B and C, and that's this angle over here. So by the properties that angles in the same segment are equal, there's a property which says if this is 19, then if there's another angle on the circumference originating from the same starting point, then that would be 19 as well. So this comes out to be 19. So if this is 19, now I can find this angle over here, which would come out to be, this angle can be found, and from that I can find y. Or in fact, what I'll do instead is y equals 58 plus 19. Instead of finding blue angle, then subtracting the blue angle from 180 to get the green angle, I'll directly find the green angle by using the property that exterior angle, which is y over here, equals to sum of opposite interior angles. So I'll just do y equals 58 plus 19, which gives me 58 plus 19 is 77. So that's the answer.